So for quadratic equations is a second-degree equation, and it can be written in standard form of everything on one side of the equal sign, 0 on the other. So ax squared plus bx plus c equals 0 is considered standard form. So that's your first step, is to get it written in standard form, or get it written set equal to 0. Then you're going to factor the polynomial, which is usually on the left-hand side. And then you're going to apply the zero product property to set each factor equal to 0 and solve. So that's our process. That's solving quadratic equation by factoring. We're going to go through 4 different methods of solving quadratic equations. The easiest is by factoring. So with this first one, we want it written in standard form, which means we have to move the x and the 3 over, so we need to subtract them. Which gives us 2x squared minus x minus 3 equals 0. Now we want to factor. So we have a 2x and an x. Now factors of negative 3, which combined with the 2 gives us a negative 1. So if we do a negative 3 and a plus 1, let's check that. 2x times 1 is 2x. Negative 3 times x is negative 3x. 2x minus 3x gives us the negative x, so we're okay. So we have it in fully factored form. So we go to the last step, which is to set each factor equal to 0. And then we work it like we just did for the linear equations. We add 3 to both sides. So we have 2x equals 3. We divide both sides by 2. So x is 3/2. We subtract 1 from both sides, so x is negative 1. In most cases, with a quadratic equation, you will have 2 answers. Now, we're lucky, this one is already written in standard form. So we're going to factor. 3x and 3x. We have to have the same sign. For it to be positive, that sign's going to be negative. So negative 1 and negative 1. 3x times negative 1 is negative 3x. Negative 1 times 3x is negative 3x. Negative 3x plus negative 3x is negative 6x. Well, in this case, since both factors are the same, we really only have to set one equal to 0. Unless you want practice and you want to set the second one. So add 1 to both sides. We have 3x equals 1. Divide by 3. We have x is 1/3. Let's factor this next one. Notice we've been using x a lot. We can really use any letter as the variable. So this next one uses z. So we have z and z. Our last sign is negative, which means we have a plus and a minus. We now need to find factors of negative 12, which when added gives us a positive 4. We could do 4 and 3, but that doesn't give us a positive 4. How about 6 and 2? We do a positive 6 and a negative 2. To have a negative 2z plus 6z gives us the 4z. So z plus 6 equals 0. and z minus 2 equals 0. So z equals negative 6, and z equals 2. Now this next factoring is a little more complicated because we have 4 terms. What we need to do is group them. So we'll group them in pairs. So we have x cubed minus x squared, then plus negative 4x plus 4. Once we group them, we find the common factor in each group. So between x cubed and x squared, our common factor is x squared, and we're left with x minus 1. Here, because we want a minus as the second sign, we're doing negative 4 as our common factor, which also leaves us with x minus 1. This now means we have x minus 1 as a common factor, and we're left with x squared minus 4. However, we can factor x squared minus 4, so we have x minus 1 times x minus 2 times x plus 2 equals 0. So we have 3 factors. So x minus 1 equals 0, x minus 2 equals 0, and x plus 2 equals 0. So we have x equals 1, x equals 2, and x equals negative 2 will be our 3 solutions. The next problem is similar. Group the x cubed plus x squared plus negative x minus 1. X squared, x cubed has x squared as a common factor. Negative x and minus 1 has a negative 1 as a common factor. We now have x plus 1 as a common factor. We're left with x squared minus 1. However, we can factor x squared minus 1. So we have x plus 1 times x plus 1 times x minus 1 equals 0. X plus 1 is a factor twice, so we're just going to use it once. So we have x plus 1 equals 0, and x minus 1 equals 0. So x equals negative 1, and x equals positive 1. And that's it for the factoring method. Our next method is a square root method. Now for the square root, you have something squared on one side of the equal sign and a number on the other side. And we go through the idea that if x squared equals some number, then x is the plus or minus square root of that number. In these cases, we don't have a first degree term. It's only a second degree term and a constant. And we have to remember the root can either be positive or negative. We're not strictly talking about the positive root. So in this first one, we have x squared equals 4. We take the square root of both sides. Square root of x squared is x. and it's plus or minus square root of 4, which means x equals plus or minus 2. Second one, if we take the square root of both sides, we get x equals a plus or minus square root of 5. 5 is not a perfect square, so we can just leave it. With this next one, we have a quantity squared equal to a number. Same process. Take the square root of both sides. Now we have x minus 2 equal plus or minus square root of 16. Add a 2. We have x equals 2 plus or minus square root of 16 is 4. So x equals 2 plus 4 is 6. 2 minus 4 is a negative 2. This is a little easier than multiplying out the x minus 2 squared, setting it equal to 0, and then factoring. Same process. So x minus 1 equal plus or minus square root of 4. Add 1, we get x is 1 plus or minus, where square root of 4 is 2. So 1 plus 2 is 3. 1 minus 2 is negative 1. So that's the square root method. You can only use it if you don't have a first degree term, only something squared equal a single number. And this leads us to completing the square, because this is actually going to be one step once we've completed the square. For completing the square, you need to adjust the left side of the equation so that it becomes a perfect square trinomial. And whatever value you use, you add it to both sides of the equation, and then you use the square root method. So if we have x squared plus mx and we want to make it a perfect square, we're going to add the coefficient of the first degree term divided by 2 squared. So it becomes x squared plus mx plus m over 2 squared, which factors to be x plus m over 2 quantity squared. So let's apply that to some problems. So first thing we have to do is get the constant term to the other side. So we have x squared plus 5x equals a negative 4. So we need to take 5 over 2 and square it. And we need to add that to both sides. Now the left-hand side we're not really going to do anything else with, except factor it as x plus 5 over 2 squared. Right-hand side, we have to do a little bit more work. So we have negative 4 plus 5 squared is 25. 2 squared is 4. So now we have to write the negative 14 with the denominator of 4. So this gives us x plus 5/2 squared equals negative 16 over 4 plus 25 over 4. So x plus 5/2 squared equals 9/4. Now square root of both sides. So x plus 5/2 equals plus or minus square root 9/4. Subtract 5/2. So x equals negative 5/2 plus or minus 3/2. Negative 5/2 plus 3/2 is negative 2/2, which is negative 1. Negative 5/2 minus 3/2 is negative 8/2, which is negative 4. So this equals negative 2/2, negative 8/2. Now the second one is already set up with a single constant on the other side. So now we have x squared plus 4x plus 4/2 squared equals 21 plus 4/2 squared. Well, 4/2 is simply 2, so this becomes x plus 2 quantity squared equals 21 plus 4/2 is 2 squared is 4. So x plus 2 quantity squared equals 25. Square root of both sides of x plus 2 equals plus or minus square root of 25. Subtracting 2, we have x equals negative 2 plus or minus square root of 25 is 5. So x equals negative 2 plus 5, which is 3. Negative 2 minus 5 is negative 7. Now, completing the square kind of leads us to coming up with a formula which we will use if it can't be factored and if we don't want to go through completing the square. And I actually have on here the derivation of the quadratic formula. Basically, we get the quadratic formula by completing the square. You really only need what's down here at the bottom. That's the quadratic formula. A, B, and C are coefficients of the variable. A is always the coefficient of the second degree term. B is the coefficient of the first degree term, and C is the constant term. Now, we can use this quantity that's under the radical to figure out what kind of roots we have, or if we have any real roots. That quantity is known as the discriminant. It discriminates between the different types of roots. So if it's greater than 0, that means we can take the square root of what's under there and you have 2 unique real roots because it's a plus or a minus. If it equals 0, you're going to have 1 real root. If it's less than 0, you have no real roots. Let me just write the quadratic formula again since we're going to be working with it. Minus b plus or minus the square root b squared minus 4ac, the whole thing, over 2a. Now, if you do this and come up with a two whole numbers, it means that it probably could have been factored, but we just couldn't think of the factors at the time. So the first thing you need to do is identify A, B, and C. Well, A is the coefficient of the second degree term, so it's 3. B is the coefficient of the first degree term, so it's negative 5. and c is the constant. Now, sometimes it may not be written in standard form, so it may make it a little more difficult to figure out a, b, and c. You can always go back and write it in standard form. Now, plugging the numbers in. X is negative of a negative 5. Remember, the negative is in the formula, then we put b. Plus or minus square root of negative 5 squared minus 4 times 3 times 1 over 2 times 3. So negative of a negative 5 is a positive 5. 5 squared is 25. Negative 4 times 3 is negative 12 times 1 is negative 12. The whole thing over 6. This gives us 5 plus or minus the square root of 13 over 6. And this is what we give as our answer. We don't give the approximate answer of figuring out what square root of 13 is unless it's an application problem. We actually want numbers. Now, if we look at this next one, same thing, identify A, B, and C. So A is 1 because there's not a coefficient written. B is negative 4. C is 2. So plugging the numbers into our formula, minus B plus or minus the square root of B squared minus 4 times A times C, the whole thing over 2 times A. So negative minus of a negative 4 is a positive 4, plus or minus. Negative 4 squared is 16. Negative 4 times 1 is negative 4 times 2 is negative 8 over 2. So we have 4 plus or minus the square root of 8 over 2. Now at this point, this is how you would leave it because we haven't gone through how to work with radicals yet, how to simplify radicals. If you know how to simplify radicals, it becomes 4 plus or minus 2, radical 2 over 2. We have a common factor of 2 in the numerator. So we have 2 times 2 plus or minus square root of 2 over 2. The 2's cancel and we're left with 2 plus or minus the square root of 2. Now in the next one, it's the same thing, except now it's not set equal to 0. We need to move the 4x to the left side, so we're going to subtract it. That gives us 3x squared minus 4x plus 2 equals 0. A is 3, B is negative 4, C is 2. So x is minus negative 4 plus or minus the square root. Negative 4 squared minus 4 times 3 times 2 over 2 times 3. This gives us 4 plus or minus the square root of 16. Negative 4 times 3 is negative 12 times 2 is negative 24 over 6, which is 4 plus or minus the square root of negative 8 over 6. We cannot take the square root of a negative number, so our solution is no real roots. Because we can't do this. With the last one, again, we're using y instead of x. That's okay, same process. A equals 4, b equals -1, c equals 2. So now it's y equals negative of a -1 plus or minus the square root, -1 squared minus 4 times 2 over 2 times 4, which gives us 1 plus or minus the square root of 1 minus 32 over 8, which is 1 plus or minus the square root of -31 over 8. Again, we can't take the square root of -31, so our solution is no real roots. So you have 4 methods for solving quadratic functions.